So all yours, Rick.
Thanks, Rich. So let me add my voice to thank the organizers for this today, and also welcome all of you to the session. And I believe there'll also be a poll that's coming up now that will kind of ask about your background. That will help the gang out to organize future ones. And also, I wanted to encourage you again to add any questions to the ones I will come up with and put them in the Q&A box, and we'll try to go through those with some priority. My background is Rich. I'm an advisor with Silicon Catalyst. I am also an adjunct at Stanford. But before that, I really designed processors and radios a bit. And so I overlapped with a couple of our panelists today. I kind of stopped designing processors when the industry started consolidating a lot. And there were only a few places left to work. And then I went into a chip startup that was doing radios, Wi-Fi, became eventually part of Qualcomm. And I kind of left that because I thought the fabless industry was kind of dwindling. And so I have established I'm not a very good prognosticator of where the future lies. So I hope you'll feel more, you'll get a better sense from our panelists today. You know, in my defense, there's been a bunch of tidal forces that have really changed. And you know, no small part of it is kind of this huge ride that many of us had on Moore's Law has slowed a great deal. Denner scaling stopped us a while ago, voltages stopped scaling. So we became very power limited in what we could put together, even if we could get the transistor density. And now it's the case that really the advanced nodes are for those who truly need, have extraordinary need. And so it's creating this moment of creativity. So this moment to look around and to try other approaches that where we just relied on sheer technology advance, we now have to look a little more thoughtfully at where we could go. And same time as that's happening, we have this explosion of data, this sea of sensors, a lot of it's video. We just really have this urge to find information, meaning in all this data about us, the computing, the image processing, the extraction of feature, all this stuff is just exploding around us at the same moment. So we have this sea of data, we have this need to find other approaches, and it's given a rebirth to parallel computing in a huge way. And we'll talk about that a little bit here. We've also, you know, communications has just exploded at the same moment. The opportunities for local and wide area and local communication and wired and wireless has just grown with its own version of Moore's Law of connectivity. So there's a huge amount of connectivity around all of this computing, around all of this computation, around all of this data. And so we're kind of becoming an epic of a new epic for computing, a new beginning for computing, and a resurgence of the fabless industry. So with that, I will now turn to our panelists, and I'll ask them to introduce themselves a bit and speak about their companies, and also offer a first question to kind of give a springboard to start this discussion going. So first, I'd like to ask Dr. Doug Kirkpatrick at Eridan to speak a little bit about his background. His field is communication, which was my most recent one with Qualcomm. And so my question to you also, Doug, as you do your introduction is gosh, it's a vertical market dominated by strong vertical players. So how does a startup really get a traction, get a footing, get a beginning in a market like that? So with that, Doug? Doug?
Let me make sure the mic is on. There we go. That's a classic question. I didn't go to Cornell. I have 4 people from Cornell working for me. But that question is actually phrased by one of my classmates from MIT, Clay Christensen, in The Innovator's Dilemma. These big companies, the problem they have and the opportunity that it makes for us is they develop a blind side. They develop a blind side to the train they're on, and they don't see the train that's coming from the other side. And small companies necessarily innovate better and faster. We don't have legacy products that we have to be slave to. We're not defending a turf. We're not defending customers. We're simply trying to innovate outside the loop. And as a consequence, it gives us a massive opportunity to do that differently. Now, I mentioned I went to MIT for my PhD. I almost went to Cornell as a prof and ended up going instead to do industrial research, where I was discovered by a DARPA program manager, and then ultimately through many, many trips and going out in the commercial lighting industry, became a DARPA PM. I'm assuming everybody here knows what DARPA is. And then ultimately came out into the venture capital industry and spun myself back into doing line work again, because for all respect to all of the investors that are on the meeting, for me, being an operator is substantially more fun than being an investor. And it's about fun. Then that's where the innovation comes from. It's passion.
Oh, thanks, Doug. Our next panelist, may I turn to you, Alex, Dr. Alex Behfar. Alex, you're focused on the world of energy and the management of energy, and it's important at the micro level with chips, it's important at the macro level in vehicles, it's important everywhere, but it's a very different industry than communications. It's there's many players, it's very conservative. So let me ask you to please say a word about yourself and your company, and also how you are tackling your angle of entry for this very, very different market than Doug's.
No, thank you for your question. I appreciate that. Just a few words of introduction. Chairman and CEO of Odyssey Semiconductor. It's actually an Ithaca, New York-based startup. So, and populated with a number of graduates of Cornell, as you can imagine. I'll talk a little bit about Odyssey. Odyssey is focused on power semiconductors, particularly made out of GaN. I'll address some of the areas that you pointed out, like energy, but we are in several verticals that we focus on. It's essentially solar, electric vehicles, industrial motors, wind power, smart grid, and electric train propulsion. There is a huge appetite out there for high voltage power transistors that have significantly low resistance in silicon or silicon carbide, and that's really what our company is focused on. And as I answer your question, we'll address some of those some of the benefits that come from that. Prior to this activity on Odyssey Semiconductor, I had a startup also based in Ithaca, New York, called Binoptics. This was on semiconductor lasers. Sold that back in 2014 to a company called MACOM, public company. And prior to that, I worked at IBM for just over 10 years. And that was right after finishing PhD at Cornell. So to your question regarding how conservative this market is, and how difficult it is to address it. When we look at silicon, you talked about this. You look at Moore's law. You look at the struggle to keep things going with silicon, and it's getting tougher and tougher. And really, silicon has been an absolute workhorse for 40 years and still will contribute tremendously going forward. But in certain areas, we feel that in order to keep that curve going and innovation going and performance that customers expect going, it's time to pass the baton. And that's going to compound semiconductors like silicon carbide, gallium nitride, and others. Why are we choosing this moment in time to address these markets? It's because we are in a massive transition from fossil fuels to clean energy, from the internal combustion engine to electric vehicles, to coal and gas power generation, to solar and other things. So when you add all this up, it is the right time to be addressing these opportunities and markets. Like I said, we are focused in a very unique place, which is high voltage GaN transistors. These are 1,000 times less resistive than silicon, 10 times less resistive than silicon carbide. And really our goal with these technologies is to contribute to electric vehicles, to solar power conversion and other things by having less loss, smaller sizes, and less weight. So that's really why we're doing this at this moment in time.
Thanks, Alex. This disruption of opportunity from below and technology and the change in markets from above is really giving you quite a wind behind you. So let me turn now to Dr. Veerbhan Kheterpal. Veer, you're a serial entrepreneur. You've done this more than once, probably been a bunch of panels around all the technologies you've been culturing. You picked a different market still than the last two. Yours is about computing, and particularly in the world of machine learning and AI, there's fewer things dominating well, I guess they're electronic pages now of our industry than machine learning and where it's going. And so I guess please introduce yourself, your company, and maybe say take a moment or two to speak about why you're tackling this market and what your opportunity is in the same spirit that Alex and Doug spoke of.
Sure. Thank you, Rick. Hi, I'm Veerbhan. I'm the CEO and co-founder of Quadric. And like Rick mentioned, I've been through, the pains and gains of multiple startups before. And after every one is done, I keep telling myself, this is the last one, I'm done with startups, but it keeps happening again. I guess it's something to do with what Doug said is, what's in your DNA. You love to create something from scratch, and, creating a whole company from scratch, a product, team, everything's certainly extremely exciting to me and my co-founder. So the three of us, we founded this company almost 3.5 years ago. We saw a huge opportunity on the edge, tons of devices, tons of applications that could leverage the data coming at the edge, right? Think of cameras, think of radar, LiDAR, innovation in all those edge devices, right? And so but before this startup, right, we were coming from, we did a Bitcoin mining company before this that was acquired. And what we learned there was it's extremely difficult to build companies, especially if you're focusing on, you have a product or component, which is silicon based, right? If you go too specific, if you're an accelerator of certain kind, it can get very commoditized fairly quickly. And when we saw this space, computing at the edge, right? We were building a robot, and we had learned that it's more than AI and machine learning that this space is going to need from an innovation standpoint. And we built that into our product, both from software and hardware standpoint. So we handle the entire application today of what can be done with our platform. Before that, I've also had a company in CAD software space that was also acquired. So I've seen a bunch of multiple spaces, and I can tell you, this is the most exciting space to work in. I'll keep it to that. Thank you.
Thanks very much for that. All right, our last but not least panelist, Dr. Shahin Farshchi, represents the investment side of this house. I think I could have been in a panel talking about the demise of the silicon and the fabless industry, not half a dozen years ago. And the world has just completely changed. And part of it is this investment flow and opportunity that you're reaching for. Could you please introduce yourself and Lux, and maybe say a word or two about why you think this resurgence is happening now, what opportunities it brings?
Absolutely. So my name is Shahin. I'm a partner at a venture capital firm called Lux. We've been around for about 20 years. We were co-founded by a Cornell alum, and we have 2 members of the team that are also Cornell alums. So we are very excited to be part of the family. And we've also funded Cornell spinouts as well, obviously, as a result. So I naturally have a semiconductor background. I joined the firm about 14 years ago while I was doing a postdoc at UCLA. My background is actually in MEMS and analog circuit design. And at that time, in fact, I can thank MEMS and kind of fabless chip companies as being my entry into venture. At that time, we're still at the tail end of those companies being popular for venture capitalists. So I reached out to a bunch of VCs saying, hey, I'd be happy to source deals, diligence companies, pro bono. And a lot of them said, sure, send us deals. And Lux was actually very proactive and said, we'll send you an email address, we'll give you business cards. And please, we'd like you to go out there and scout for deals on our behalf. And being on the West Coast really helped me. So I have semiconductors to thank to get me into venture, as ironic as it may sound today. And it's been a delight doing this ever since. So my first investment was a company called Silicon Clocks that was doing MEMS and silicon for timing applications. We sold that to Silicon Labs. I did SiBeam, which is doing RF CMOS. And that was for personal area networking. That was acquired by Silicon Image. And so we are obviously very active. Fast forward several years, I led our investment in Nirvana, which we sold to Intel. I led our investments in Mythic, which is repurposing flash memory for edge inference, and Flex Logics, which is also doing IP for reconfigurable logic and SoCs. And they also have an inference chip effort that's underway. So we as a firm continue, probably because of our DNA, continue to be very excited about semiconductors. We're investing out of a $2.5 billion AUM, billion-dollar pool of capital today. We cut checks from, I don't know, anything from a few $100,000 to get a professor and a student right off the ground, to a $10, $20 million check to lead a B or C round. And we look at ourselves as long-term capital partners for our company. So we set aside a multiple of that initial investment so it can be long-term partners and continue funding the companies to the point where they can generate a multi-billion-dollar outcome. To your question, Rick, on semiconductors today versus maybe 7, 8 years ago when they weren't as popular, I think a lot of it has to do with the new use cases that are available. I feel like a few years into my career as a venture capitalist, during the financial downturn, the incremental innovations that came about were very difficult to achieve. So it took an army of PhDs to generate some kind of marginal advantage over the state of the art. And obviously, as most of us know here, those types of what Clayton Christensen likes to call, sustaining innovations are not a basis for successful startup companies. And what we've seen over the past couple of years is these types of innovations opening the doors for new market opportunities, for markets that may not be in the domain of incumbent companies, new use cases that may not be interesting or may not be as well understood for a big company to go after, and hence the opportunity for startups. When we met Nirvana back in 2015, they were making accelerator chips for cloud training applications. That was not really a market that the incumbents had a stranglehold on, that had deep channels into, and they were trying to basically displace. They were able to build out that product, and Intel ultimately bought them to be able to go out and build that market opportunity for them. And so I feel like as if the markets have changed to the point where there is novel opportunities that make it advantageous for startups, as opposed to 7, 8, 10 years ago, where startups were going head to head with shinier objects in existing markets that were already dominated by the incumbents. And I hope that's a trend that continues.
Thank you. Thanks very much. This missed use cases, these missed markets, there's a lot of opportunity. You heard of Yes Money. If you have ideas and opportunities, please reach out. Okay, that's the panel we have before us. I'll ask a few more questions, but I'd really encourage you to provide some questions in the Q&A box, and I'll try to also pick them up as they come. We have a few ahead of time. As companies start, one of the things well, I'm an advisor with Silicon Capitalist, and so I have to wonder about the role of advisors in startups and getting going. And that was one of the questions I wanted to ask a couple of you about that. What role do you look to advisors to help you most with? And Maybe Doug, I know we had some discussion of this before. Why don't you begin with kind of what the role of an advisor is for a startup?
So it's easy to start with what the role of an advisor is not, and then go to where we see the roles of an advisor. We don't need advisors to come in and help us with the technology. We have really, really good people. I mentioned, 4 of our staff are from Cornell. We have 20 people in the company, and every single one of them is top notch. But what we really get valuable inputs from, and I'll name the one that's our shining star, is a guy named Yoshioka Chika, who was formerly the CTO of Sprint and the lead advisor to the chairman of SoftBank. And it's really helpful when you have an advisor that comes in and says, I was in a network operator and these are my problems. This is what I need you to solve. I am advising one of the largest investment firms in the world, and this is how we see the world, and this is what we look for. Those types of inputs from an advisor, unvarnished, telling you you're being stupid. If you're being stupid, it's very much valuable to stop doing something dumb, right? That's means you're directing those energies in a much better way. So your advisors need to be able to speak to you plainly, and they need to be able to provide something to you that you don't have organically. And one of the strongest capabilities that we've seen are advisors that have a reach either into our direct customers, or in Chika-san's case, our customer's customer, right? Because we will sell to somebody who makes a box, who sells to Sprint, who sells to Verizon, who sells to NTT Docomo. And so if you can understand what that motivation, you've heard me say this before, right, Mike? I didn't get a very complicated education at MIT. I learned 2 things, right? Stuff flows downhill, and you can't push a rope. My advisor told me when I showed up as a first-year graduate student, when you've learned those 2 things, it's time to write your thesis and leave. Well, this is that case. It's in business. You can't push a rope. And this is indirectly what Shahin's talking about. One of the things that we've discovered with this explosion of these new use cases is there's a lot of people who are now pushing on new ropes, and that opens new business cases. And that's the other side of what those advisors bring to you, is if they can tell you this is how you will get Verizon to pull on your rope, that is a massive help.
This connecting technology with real problems is critical to the true success of a startup. And so I wonder, if you're in, Alex, do you want to offer a comment about the role of advisor or connecting those problem and opportunity?
Yeah, I'd be happy to. I mean, one of the key things that I think helped us in our prior company achieve the success was really we had technology platform. We didn't assume that we knew it all. We really, it's easy to get into that mindset that you think you know where everything's going to go, where the problems are. I think that's a very bad assumption to make. We got on the road at the time, no COVID, right? This is many years ago. We got on the road and met with 30 companies. And the idea was, what keeps these guys up at night, or guys and gals? And, what is it that they want? And more importantly, when do they want it? Is there a good overlap with what we can provide and what they need? And really being willing to go away from opportunities unless it really, meets a certain criteria. So qualifying leads, if you will, and making sure there's a good fit. That ended up really serving us very well. And, we were very happy to say we were able to grow and capture 80% market share in 2 major segments of semiconductor lasers worldwide. So, but that came not because we knew it all, right? It came because the customers told us. And that ability to listen and really hear what they're telling you, I think, is critical. And I think if you have good advisors, that's what they're going to advise you.
Thanks, Alex. Actually, maybe I'll ask you a different question here. One that is this, doing this over and over again. I did one startup. It was a huge effort. It was big. It was a giant effort. And you're doing it over and over again. You could obviously have a comfortable life in academia or in industry or with your last, but yet you dive in again and again. And a lot in the audience here are probably also wondering about whether it's a moment to dive in. What really propelled you to take such leap again?
Yeah, I'm going to be honest here. The first startup, right, that came out, I don't know what I was doing, honestly. It was right out of my PhD program. It was, by the way, one of the fastest PhDs at Carnegie Mellon, 2.5 years. It ended up becoming a startup almost by accident, and it was exciting. I was relatively much younger, and I jumped into it feet first, and it was the most, I'd say, the most valuable experience I've ever had. And the one of the things I learned, right, the first startup to the one today, right, huge difference is, as my first startup, I was trying to sell what I could build or what I had built, right, during my PhD. So it was this software work. I had done some algorithms. It was disruptive enough. And so there was a company, and now I was out in the world trying to sell that technology and that software. And then now, that has flipped around after having done 2 startups. My advice is don't try to sell what you can build, build what you can sell. And that's where I am today. And, a whole lot more confident on what we can do with the team we have and what we're building. We're bringing some very exciting stuff to market very soon. But coming back to your question of what keeps me going again and again is, I think I have this insatiable thirst to learn more and grow more. And the maximum growth I can promise everyone listening to the talk who's considering startups or going to Intel is you are going to grow tremendously much faster in personality, in knowledge, in skill, capacity, all of that in a startup much faster any day. And I remember this conversation I was having with my co-founder, and he said, it's only been 3 or 4 years since we started this company, and I don't recognize who I was 4 years ago. Who was that guy? I don't know that guy, right? When he sees or reads his own work, he's like, I don't know who that was. I'm a totally different person. So, if you want to lead multiple lives within the same life, yeah, go do startups again and again.
Hey, you seem to wear it better. I got a lot more gray in mine. Well done. Thank you. All right, let me, speaking of difficult startups, one of the questions that was posed earlier was, the semiconductor field may not be one for the faint of heart. It seems like if you're within an academic setting, you're looking out to get a company going, it might seem like there's formidable obstacles in trying to get a chip company going. And I was thinking of the people here. Shahin, perhaps you have one of the broader perspectives because you're funding a number of these. And do you feel that that's true? Do you feel that those are obstacles much easier to clear these days, and that shouldn't be your worry? Is starting a semiconductor company as hard as one might think? Oh, you may be on mute. I'm not sure.
Yes, it's very hard. Thank you. Sorry. It is extremely hard. It is extremely, it's probably more difficult, in my opinion, today than it was when I first started doing venture. The sense that I got when I was doing venture was that people would come out of their PhD programs or come out of labs and continue what they were doing before. And investors would come in anticipation of some kind of an arbitrage opportunity where they would come in, they'd put capital to work, and they would license technology out of a university, de-risk that technology, and then expect to see a large value inflection on the company, whether that's in the form of a up round for future financings or if it's in the form of some kind of an M&A event to an incumbent company. That arbitrage has gone away as a result of a lot of the activity that's going on right now and the rate of innovation that's happening at the incumbent players. And so an incumbent player today actually finds it cheaper to innovate in-house than to acquire a fabless chip company. Back in 2000, if you were Broadcom, you would spend $1 million a PhD and acquire a Bluetooth CMOS company, and that's what they did with Innovent. Fast forward to today, given the stock price of these companies, it's not as cheap for them to acquire these companies, even at lofty prices. And when you couple that to the cost associated with the EDA tools, with back-end verification, with the talent that you need to bring on board, it's very expensive to reinvent the wheel outside of these companies and simply de-risk technology. So to your question, Rick, yes, it is harder because that is not enough. That is just table stakes. And table stakes are more expensive outside the large companies than inside. So you have to go beyond that and create disproportionate value. And the way you do that is by solving the customer question, by solving the market question, by building the software tools, by building an ecosystem. And that's extremely difficult for a startup to do. But the startups that do that successfully are the ones that are valued for exorbitant amounts of money. So the classical, okay, we're going to tape out a few chips, maybe get a couple design wins, get bought for a few $100 million. For us, we don't make money that way, unfortunately, anymore. And for us, it's either you're an N of one company and you get acquired by a desperate cash-rich incumbent, which was Intel and Nirvana, or you have to go all the way and build a real business, which is what we're building with Mythic and FlexLogix. And it hasn't been easy.
Actually, we got a question from one in the audience, from Chris Rowan, and it kind of feeds off of that. It was, he writes better than I will just read it for you. The sweet spot for chip incumbents appear to be really big digital designs with big software stacks. Exactly what you were saying, Shahin. And the sweet spot for startups seems to be the narrow well written, narrow artistry of clever analog mixed signal circuits. He wonders if that's true or not, and he's especially curious if there's any counterexamples of maybe a large system digital program that's been successful, that's really gained traction. Anyone? I mean, Shahin, you're a natural person.
Yeah, I wish that was the case, because if that was the case, I would be a rich man. So, for example, Mythic, they have solved the analog problem. They are doing inference in the analog domain, but they still are not out of the woods. They need to build the whole software stack. They need to build an ecosystem. They need to get design wins. They need to go and show gross margin. They need to show growth. You are correct in that there is value that's created in doing those things. But at the end of the day, you have to go out and do everything else as well to be able to lock in that value. Now, the comment on the incumbents being experts at the big designs, I would assume that that's correct. But if you look at companies like Nuvia that just raised $238 million to go out and unseat Intel with an x86 replacement in the cloud, it could be, I personally am not an investor in that company, but it could be that even doing the very large digital designs could also start becoming in the realm of startups. But again, they have to go all the way. This company had to raise hundreds of millions of dollars in anticipation of the expenses that will be incurred until it can show some kind of value inflection. And that's likely going to be in the form of building hardware and software and all the support that they need to be able to build a business.
I have a very quick point here. This question reminds me of one of our investors' thesis, which is, as we go down technology nodes, creating, like for a large company, porting their previous design, right, large, huge digital design over to a new node, is getting fairly complicated. It's going through the roof in terms of what it takes even for them to move over. And so one of our investors actually has a thesis on, hey, if you could have a computing architecture which was 10x or 20x easier to even build, all digital with software on top, because it's rethought of from regularity, homogeneity. It's not a hodgepodge of blocks. that's put together like typical CPUs with a host of other things around them, right? That can be very powerful as a driving force behind why you should reinvent a new digital architecture as opposed to sticking to analog, right? And we've seen some of that played out where a very small team at Quadric, we taped out a billion transistor chip very recently. A very tiny team. I'm not going to say how many people, but very small team. So I'm seeing that thesis play out where it was super easy for us to tape out a very useful large digital circuit and we're building the software for it as well on an advanced node because the architecture is very homogeneous and uniform.
Thank you. Thanks. Thank you, Veerbhan. There's hope. Actually, thinking of the clever artistry of analog design, I couldn't help but think of you, Alex, as I read that. And I know I won't ask you about clever analog, but I will ask you, the market, one of the markets you mentioned in passing was the automotive market. And certainly in the startups I encounter, a lot of people are interested in the automotive market and all where it may lead, especially in its electrification. But it's a complex supply chain of suppliers to suppliers to suppliers. So I was wondering how you're imagining, even with a clever beginning and a technology opportunity, how you're managing to slip into that established supply chain.
It's a great question. So, let's just step back. I read a couple of years ago that Mercedes-Benz had stopped doing R&D on the internal combustion engine. So we know all the major players know that the end is near, right? And electrification is going to happen. So to answer your question, it really is dependent on the players. So you may have a player that has everything in-house, a famous one that is US based, right? Does everything in-house. And then there are folks that use the traditional electronics providers that supported the automotives. So depending on how they're playing the electric vehicle, whether they're doing it in-house or they have a supplier, you have to focus your energy on really at the end of the day, who's going to build the power converter, who's going to be your customer. And if that means going to the electric vehicle provider, you go there, and if it's their supplier, you go there. But let me, if I may, just make a comment. I think we kind of look at silicon and we look at these very exotic facilities that TSMC has, Global Foundries, others, and the costs associated with that is astronomical. Fortunately, for compound semiconductors, it isn't as bad. We can use the hand-me-downs of silicon and still get tremendous benefit, right? So a fab that we put together for compound semiconductors is a fraction of the cost of the fabs that silicon has. So I would say, we have a fab. We had a fab for Binoptics, and that was part of the innovation. That was what we could bring to the table. And by the way, it creates unbelievable gross margin and net operating percentages. It's really fabulous because you can control a lot of things.
Thanks, Alex. That's good. I know that Doug has a conflict at 1, and so he will need to leave. So let me slip one last question for Doug. You have this background as a DARPA PM. I can certainly speak for Stanford, and I'm sure Cornell as well, that DARPA funding and NIH government funding is a huge part of what pushes forward research. But there's also this commercialization. And do you think that there's opportunities for federal fund, for government funding to help the commercialization of products out of academia and elsewhere?
Absolutely. I mean, the DoD 5G to XG initiative they have out there is one of the examples where they're pumping about $1.5 billion. Now, most of that is for implementations, but a lot of that is putting on a pull for things that they can pull out of academia. So there's probably about 10% of that, which is $150 million, which in an academic environment is not chump change. The other side of that too is that with the new administration, you're going to see a renewed emphasis on that type of spending as well, probably. So I would anticipate that, let's call it harvesting, right? There's two kinds of investing into academics and early stage. There's foundational investing, which is doing early stage research. We don't know what it's going to yield. We know there's an interesting problem, and we're going in search of new technical capabilities. For what? We have no idea yet. And that was one, if you think about DARPA, one of the benefits of DARPA is there's really two DARPAs. There's the tech base offices that do this foundational investing, the Defense Sciences Office, the Microsystems Technology Office, and the Biotechnology Office. They do tech base. They're not looking for capabilities, they're looking for technologies. And then there used to be two systems, and now I think there may be a third systems office. I sat in the systems office, and from a defense perspective, we made new products. So we made the first LED flashlight. We made the first very, very rapid sequencing DNA single thread sequencer. We made the first micro GPS. We made the first night vision goggles. Those are all things that are capabilities. Universities tend to play a lot in the tech base. Where universities get some really interesting transitional startup opportunities is when they transition in or they have participation in the capabilities offices. So this is sometimes difficult, but it's something I hope that this particular organization at Cornell can help catalyze Cornell participation. I know two of your professors that participate with the systems offices there that I know personally, Alyssa and Al. But you know, the bottom line out of it is yeah, it's coming, and it's going to be coming in a big way. And for students that are interested in the startup opportunity, it's really helpful to get early exposure to what it's like to do R, to do D, to make a product. Those are different things. I do apologize, I have to step away. I can be reached a number of ways from the hosts here. If you have direct questions for me, I'll be doing my best to answer them. Thank you, Rick. Thank you, everybody.
Thank you as well, Doug. All right. We did have a few questions that came in advance. Let me fire off one that just seems aimed at you, Veerbhan. How do ML hardware architectures and more traditional computer architectures coexist? That was the phrase. You can take that. How do they coexist?
I think that it reminds me of this conversation just a few minutes ago we had about new applications. And you know, traditional architectures have their place and will continue to be important. You know, think of CPU, GPUs, the purpose that they've been built for is not going away. And certainly incumbents are trying or adapting or bolting on, you know, features for their originally designed architecture to be useful for these new applications, right? And that's where, as a startup, we have an edge because we built something from the ground up for the new application, right? But the way it's going in the marketplace, I see these two coexist very peacefully. They have their, you know, place in terms of what workloads they solve for, and the industry is certainly starting to standardize around protocols, bridges where different computing systems can live in an application and interact. If you saw there's some data center standards coming. There's standards on the edge as well that are being worked on.
Thanks. Good. Thanks. Actually, another question came in that has you started, Alex. It's about transportation. It's a trigger off the automotive questions, really. And the fellow, George Estef, submitted this question. It was really in the transportation space, Tesla is really standing apart as an innovator. And you can use the example of the battery developments that they're pushing so hard. But it seems like the legacy vehicle companies have very little idea of how to innovate or when to innovate and all. So he wonders how the power electronics startup can reach these, I guess this is recorded, laggards in the industry. Alex, how would you answer that question of connection of opportunity with people who don't really perceive it?
Yeah, so let me answer it this way. I think you know, there are a lot of opportunities. You know, when you look out there, There is a tremendous number of companies that have been formed to address, for example, electric trucking, right? And you know, I mean, you look at CNBC, you see, you know, some of them interviewed. I think there was one last night that was being interviewed. So there's a lot of great startups, and some of these are making arrangements with the big three in this country. There are other relationships, and you know, worldwide with others. So my gut feeling is that, you know, whether you have it, you know, from our perspective, whether you have it with a major player that has it in-house, or whether they're working internally or externally on those power converters, you can go in and really see if you can address their pain points, and also find out, is this going to happen in the next 2 years, or is it 5 years from now? So those are the things that I think you need to ask. But yeah, you know, definitely you can find the suppliers, you can find who's doing the work, and then engage with them and really see, at the end of the day, can you contribute? Can you help them solve the problem?
Great, thanks.
Was one more quick point there. We are seeing, and Tesla is driving this. We are seeing a lot of pull from, you know, tier ones OEMs to be more dynamic, change their systems for frequent software updates, change their systems to be more capable. And you know, we asked our question why, and their answer is straight up Tesla. Tesla is actually causing them to start to move on this, and it's pretty important that there is a driver, an innovation driver that keeps everyone on their toes.
Thank you. Thank you. And thank you, Ilan. One of the questions that came in ahead of time was, I'm not sure, it's not exactly the background of the panelists here, but it was really about new memory technology replacing silicon floating gate transistors in the near future. I wonder, Shahin, you might actually have more of a perspective on this from an investment. I know from my point of view, people have been looking for memory since I was in grad school. And there's a huge explosion of opportunity with magnetics and phase change and resistive and all that. But do you see any of them really emerging, and why?
So there's a variety of challenges as it relates to, you know, bringing technology, period, into the market, let alone semiconductor technology, and that is the incremental benefit relative to the risk. So obviously there's very little risk in flash memory. If you're making a camera and there is some kind of an incremental benefit in using ferroelectric memories versus flash, you'd say, you know what, I'd just rather use a flash. Flash wears out in 1,000,000 cycles. Well, how many times am I going to rewrite on this thing? You know, my customers are probably going to throw this in the garbage after 2 years anyway. So I'm just going to put in the flash and not necessarily take the risk on a more limited number of suppliers and potentially less support, and risk getting fired if anything goes wrong by, you know, doing ferroelectric. So I think, you know, we may be in the high tech business, but customers are very risk averse given what's at stake. And so if you're offering a new memory technology, know that the state of the art is pretty good and it's very well understood. And so if you're trying to offer an alternative to that, if it's all about more cycles, or it's faster read times, or it's faster write times, or lower power writes, or read or whatnot, then it has to be significantly better as it relates to the use case. As academics, we get very hung up on the, you know, 10x lower power associated with a magnetic or with a ferroelectric or whatnot, you know, memory, but we don't appreciate the customer kind of use case and how much they would benefit from it. And if there isn't a huge benefit, and when I say a huge benefit, I mean their ability to sell more products, be more competitive relative to their competitors, if there's not a clear use case there for them or a clear thesis for them to adopt this, then they just won't, which is why a lot of great technologies have been de-risked and have been offered, you know, on the market, but haven't really gotten much traction because there aren't that many vendors for them. There aren't that many there isn't as much support for them. Their warranties may not be as great. Like all these other factors come in, which are separate from the technology, which may limit their adoption until in the future, there is a use case. In the case of flash, there was a use case in digital still cameras where people said, wow, like, I would pay for, I'll pay extra per megabyte, to have, this thing that goes into a camera so I can take 1,000 pictures on my camera, or 100 or whatever the number was back in like the early 2000s. That is what kind of created this got the flywheel turning for flash. And I wouldn't be surprised if there will be a flywheel for magnetoresistive, memories, or for ferroelectric memories, or for phase change memories. I do expect that flywheel to happen for them too. It's just that the use cases aren't obvious just yet.
So I wouldn't approach Lux for a new memory technology unless you have a really clear plan.
We funded them. We did Everspin, which is now a public company, doing MRAM. And so we appreciate the technology is mature, it works, but it's just a challenge there, unfortunately, the market penetration part.
All right, we're almost out of time. Let me just slip in one more question that comes from my hanging out at Stanford these days. I find this interesting in publishing, this open source to be a passion there. I also, in my last startup, this opportunity with standards was an amazing thing. We just did a component in Wi-Fi that just fit within a world of standards. So I wanted to ask Veerbhan a question about it. Do you feel there's a role for these standards and open source GPU? Are there some levers there that startups can really reach for?
Yeah, I can give an example in specifically the AI use case on the edge, or even in data center. Typically before, right, if you came to market with a new processor, right, you would run into the software problem, which is like, okay, I have 50 customers, they have pre-written code for x86 and optimized. Their performance engineers worked on it. They're not going to sit and rewrite and port all their code. And even if you won a few customers, maybe for a specific reason, it made sense to port that code, right? But in the AI space, it's interesting because most of the IP, customer, neural networks, ML models are being captured in one of the packages that are popular these days. You use, PyTorch or TensorFlow. And that makes entry points for startups easier because the customer already has their design, their neural network in TensorFlow, let's say. And the startup can go in and say, you know what, you don't have to rewrite anything. Here's a push button way of running it on new hardware and getting performance and power. So the more popular, one of these frameworks gets and people crowd around and become standard, the better it is for startups. We've run into cases where customers have obscure, cuDNN implementations of their neural networks, and that's just hard for us to go support and port. And customers are certainly moving on and adopting the more standard ways of coding these up. So it helps a lot.
Thank you. I think we've officially run out of time. I think I've gotten the virtual hook. But I wanted to thank the panelists for their participation and the audience for their questions. And I enjoyed this very much. And now I think we turn now to the startup section. Thank you all.